Okay, we're going to go ahead and get started. Thank you, everybody, for signing on to today's webinar with Testforce, NI, and Computer Solutions on using Python with NI hardware and software. So before we get started, I just want to go over just a few housekeeping items. Today's webinar is going to be recorded, and everybody's going to receive a recording of this in their email afterwards. So you can share this email with anybody else that didn't attend the webinar that you think might be interested, and you can rewatch it at any time. So we're going to go through the presentation, and then at the end, we'll have some time for any questions that you have on the material. If you think of a question during the presentation, please just go ahead and put it in the Q&A box just on the right-hand side of your screen or down at the bottom if you've joined via mobile. So today's presenter is Kevin Flanagan. He's a senior software engineer of product R&D at NI. So without further ado, let's get started with today's presentation.
Hi everyone, my name is Kevin Flanagan. I am a senior software engineer with NI, and today I'm going to be showing you how to use Python with the NI platform. Both how to use Python with our hardware platform, as well as how Python can be integrated within our software platform as well. So when it comes to our view on Python with the NI platform, overall we want our platform to be open and able to use the tools and programming languages that you want and need for your applications. And so Python has become a more popular language in the last few years, and as such we've added support to it for our platform. But when we bring Python into our platform, we want to do it in a way that feels natural to people who are already using Python. And that really comes down to really trying to embrace Pythonic ideals. We want to make sure that we are object-oriented. We want to make sure that we're open source. We want to make sure that we're being clear and straightforward with our APIs, and supporting cross-platform execution wherever possible. Really embracing that so-called Zen of Python. And so to that end, I'd like to show you 3 ways that you can use Python with NI. We're going to talk about how to use Python to control our hardware, as well as how to call Python from within our software products. And finally, a couple examples of how to automate our software using Python scripts. First, I'd like to highlight using Python with our hardware platform. So our hardware is really an industry-leading hardware platform for test and measurement applications. And we want to make sure that if you want to use Python, that you can use Python to control our hardware just like you would in any other supported language like LabVIEW or C or .NET. And so to that end, we've really put an investment to make sure that most of our drivers have native NI-built Python APIs. And that includes full coverage of our PXI modular instrumentation platform. So that's these cards that you might see in a system like this, your DMMs, your power supplies, your switches, your function generators, digital pattern editors, and so on. And there are also a couple of other drivers that we have coverage for that are popular, like DACMX, XNet, and so on. Plus, because we have a really passionate community of users within the NI world, and Python also has a very passionate community, those 2 communities have come together to create some really excellent community-built API wrappers for some of our other drivers that we think are really serving that well. And we want to make sure that we're highlighting the good work that our customers are doing. So for an example of this, I'd like to show you a demo of how you can use NI-DACMX from within a Python environment. The first thing that you're going to do when trying to get started with NI-DACMX is to install the DACMX driver from our website. For the sake of time, I've already gone ahead and done this. And then this will install the base driver, and you'll need to then install the NI-DACMX package, which gives us the Python bindings to be able to talk to that driver. And so this is available publicly on GitHub. You can see all about the driver, how to install it, and some quick getting started guides. We're going to go ahead and install this Python package. So if we pull up a command prompt, we can use the public open source Python package manager pip to install NI-DACMX. and DIAdem. And so once we kick that off, you can see in just a matter of seconds, we now have installed Python support for our DAC driver. Now this Python support will also install a set of shipping examples, which can be really helpful in getting started. Or if you're feeling bold, you can jump right into an empty file. Over here, I've actually already opened one of our shipping examples in Visual Studio Code, which is kind of my Python editor of choice. And so you can see here we've got a pretty simple script. We're going to be invoking the task object from NIDACMX, which is going to be the top-level API that you talk to. Then we're going to configure which piece of hardware we're using, how much samples we want to acquire. And down here, you can see that we're actually registering a function that we wrote in Python as a callback for DIAdem. And so this allows us to execute this Python function every 200 samples and do the actual acquisition. Then we simply start the task, wait for our collection to finish, and then we will see the results with a third-party visualization library called matplotlib. So if we go ahead and run this script, you can see down in the console, we've seen our 5 callbacks. We've got our 1,000 points. We can continue on, and now you can see the actual data that we just acquired. So simple sine wave, really straightforward example, and a great place to get started. And so this is how DIAdem works in Python, but using our other drivers in Python is a very similar experience. All of our drivers follow a very similar workflow of invoke an object that manages that hardware, do configuration on it, do things on it, and then close that reference. And that's a pattern that you'll see come up over and over again whenever we're using our hardware, or even when we're integrating with other external third-party libraries. And so that's a quick demonstration of using our hardware with Python. Next, I'd like to show you our integration with LabVIEW. So if you're familiar with us at all, you've probably heard of LabVIEW. It's one of our flagship products. And LabVIEW is a graphical programming language that allows you to write your test code by being able to actually see the functions on screen and see how data is flowing from one function call to the next. It features an excellent ability to create professional user interfaces without having to get bogged down in the details of like event-driven programming like you might have in Windows Forms, or even building a UI in Python, which is a much bigger task. And of course, LabVIEW is built by engineers for engineers. And so it has a comprehensive set of tools that allow you to do all the kind of analysis functions that you might need in your data set. And because it is a programming language, we have the ability to talk to external IP through third-party tooling, third-party languages, whatever you need. And so this is sort of how Python fits into this picture of the puzzle. A workflow that we see pretty commonly is that we have people who want to use LabVIEW for what LabVIEW is really excellent at. They want to talk to their hardware, they want to get their data, they want to analyze it, show it on their UI, everything that I just talked about. But they already have existing IP in Python that they've written and that they want to be able to integrate into their LabVIEW test flow. And so to that end, we have the Python node in LabVIEW. And so it's a really straightforward API for calling Python scripts in line with LabVIEW code. It starts out by opening up a Python session, which will spool up the Python interpreter of choice. We have support for all the major currently supported Python interpreter versions. Then you'll go to a Python node. You'll invoke your script, call whatever functionality you might need from it, pass data in, get data back out, and then close your Python session when you're done with your Python task. But this flow is also very powerful because here I mentioned that the session maps to a Python interpreter instance. And since LabVIEW is sort of a has natural parallelism with parallel lines of data flow, if you open up a second Python session, you can actually get multiple interpreter instances running in parallel with each other, which is a really cool feature that is something that is a little bit harder to do in just vanilla Python. So I'd like to show you this in action, and I've got a demo prepared to show you how to invoke some Python code from a LabVIEW VI. So over to the demo box. We have a VI here that is going to be talking to our function generator and the scope that we have in here. It's going to grab measurements from that hardware, do analysis on it, and then it's going to use a Python node to communicate with a third-party Slack client, and you can actually see the test results show up there. So let's go ahead and run this. You can see data being collected here. You can see the frequency response plot, and we just got a notification over here. So you can see right here, we got our test results. They passed, as well as the graph that we created in LabVIEW. We were able to push right into Slack. So let's take a look at how this actually happened. If we pull up the block diagram of this, over at the end here, we've done our hardware configuration, and now we're building our message, exporting the graph that we created, and sending that over to this sub-VI, which is going to handle communication with Python and Slack. So we can open this up. And just like before, it's fairly straightforward. We're opening up a session, which creates our Python interpreter. We are calling this post message function that we wrote, which then takes in the message and the file and uses the Python API to communicate with Slack to post that message that you saw. And then you can close out the session to Python, and your VI is done executing. So this is, I think, a great example of one of those instances where you have this third-party library that exists, that communication with Slack. They're able to call inline with LabVIEW through the Python node. The last thing that I like to call out when it comes to integrating Python with LabVIEW is sort of the opposite of what I just showed you. LabVIEW has always had the ability to be controlled from external environments and external languages, and it's no different with Python. So we have some example code on GitHub to help you get started with this, where you can actually launch LabVIEW, put data into your LabVIEW VI, execute it, get results, and then handle that data inside of your Python code. So if, for instance, your company had existing LabVIEW IP that you now wanted to integrate into a Python-based system, you can use the power of LabVIEW right in line with Python as well. So next, I'd like to show you integration with a product that we have called TestStand. So TestStand is a product that we call a test executive, which is an all-in-one framework that allows you to develop, deploy, and standardize test processes across a fleet of testers, all in one environment. And so this features the ability to create sequences of test code that you can write in any language of choice, such as LabVIEW, C, C++, .NET, and obviously Python. It allows you to gather all of your test results into one location, create reports off of that, as well as upload to things like databases. And then the real power of TestStand comes in with its parallel testing capabilities. So it's able to manage running multiple tests simultaneously for some number of devices that you're testing. So when we see our demo here, you can see there are 4 devices that we'll be testing, and we'll actually be running those in parallel with each other to really increase throughput to its maximum. So I mentioned that when it comes to actually creating test sequences, the core of that is going to be calling steps from your test sequence. And that step can be configured in a variety of languages. And so we'll be showing you the Python step. And you can see here, you're able to point to a Python script, control the real scope of the operation that you're going for. And you have some really advanced options available in Python or in TestStand as well. So we're able to spool up multiple instances of the interpreter to do parallel tests. You can target different Python versions, and you can store object references to data that you're getting back out of Python. It's very flexible. I mentioned some of this ability in LabVIEW as well. Both LabVIEW and TestStand share a common Python layer, and so they're able to do a lot of the same things with Python. So let's go ahead and see this in action. So I'm going to show you TestStand invoking Python test scripts, which are themselves going to invoke the modular instrument drivers that I highlighted earlier when we were talking about our hardware API support. So over to the demo box. Here is our TestStand environment. You can see we have our test sequence here with a number of steps. If we take a look at this specific step, this is our step to test our blue LED on one of our devices here. We're invoking the Python script that contains our test code, scoping down to a pre-created object that we created in an earlier step, and then calling functionality on that. And this is currently configured to run things in parallel. So you'll notice that we have a couple of something called auto-scheduled resources. And these are sections that I have told TestStand can run in parallel to each other. And so TestStand will schedule these different sections to different devices as they're available. But let's go ahead and see this in action. So we can run this, and TestStand is now in the background loading code into memory, creating the thread pool that we're going to need to handle our parallel tests. And in just a moment, we'll see our test sockets get scheduled. So you can see them right here. You can see we've got 4 tests running in parallel. And if you pay attention to the steps, we're kind of moving around different parts of the test sequence as the hardware resources become available for that device. And so in just a moment, we should be done with our filter test, which is kind of the long-running test that we have in this sequence. And I believe this is the last one. We should be getting results in just a moment. And you can see we have 4 passing tests, just what you want to see from a test system. We'll go ahead and stop this execution. And now this is a look at what a report looks like. And so you can see in the report, we have inline measurement data, so you can see the result. You can see the specific measurement that we took. And you can also see charts of the data results. So these were generated by Python, and we were able to pipe them right into TestStand's native reporting. And so this is one way that you can see how you can leverage Python code within your test sequence. But more than just use Python code, you can really use TestStand in tandem with Python to enable Python to do things that aren't as easy in Python. Python being natively a single-threaded language, doing that kind of parallel execution where you're running multiple instances of Python code simultaneously with each other is something that really TestStand is able to bring to the table with Python. And so I really like being able to show that off to people. Next, I would like to highlight a product that we have called DIAdem. So DIAdem is a big analog data analytics tool that is purpose-built for engineering data. And it contains an integrated workflow with a unified search, data visualization tooling, integrated analysis tooling, integrated reporting tooling, and a big feature to be able to script the entire environment so that you can automate this whole process and get from your data to your final report in just minutes. So the way that Python really fits in, this is one of those examples of Python being used to automate NI software. DIAdem has long had the ability to be fully automated through VBScript. But recently we've added Python script to DIAdem as a first-class scripting citizen. And we'll go ahead and show you that in another demo. So I'm going to show you an example of how to use DIAdem real quick, and then how you can use Python scripting to really automate that process. So back to the demo box. And over here, we have DIAdem. The first tab that we're on here is called the Navigator tab. This is where we have the data finder, which is keeping track of all these sources on my system that I currently have test data available. So let's search for some car engine prototype data that I have put together. So you can see here, we've got our TDMS file with data. We can drag it right into our data portal. And now we have 2 data channels here, time and oscillation data. We take a look at this oscillation. You can see a little preview of the data down in the bottom right. But we'll probably want to get a much closer look at this. So over in the View tab, this is where you can get where you can configure a number of predefined views. So here is just a table view of our data. But I want to get that bigger graph. So let's drag this over. And now you can see I've got my full set of oscillation data. Now, with oscillation data, let's say I want to perform pretty basic analysis. Let's just do an FFT on this. We'll go over to our Analysis tab. And we have a number of analysis functions. I'm going to go over to our Signal Analysis section, come over to our FFT. DIAdem has very cleverly noticed that I have my time and oscillation data, and we'll go ahead and calculate that channel. So now you can see we've got the results of my calculation shown in here, as well as the 2 new channels that represent my FFT. Then if I want to see those results against my graph, I can create a new area down here. And then let's drag over this FFT data into a 2D axis system. And so now you can see, we'll make this a little bit bigger. now you can see our oscillation and the resultant FFT that we got from DIAdem. So this is the kind of basic DIAdem workflow that you might see. But let's say that we want to automate this. We want to do this in bulk for our data. We can come over to our scripting tab here. And now you can see I've already pulled up an example of how you can automate loading data and performing that FFT and getting your final view all in a single button press, as you'll see. So we have a Python script that has some code to automate preparing that view that I showed you earlier, pulling in my channel data, validating my data selection, performing the analysis, and then doing a little bit of additional scripting to get the environment in just the right place that we want to. So let's go ahead and run this Python script and see how easy it is. We can run our script here. We get some nice inline dialog prompts that tells me what to do. So we're going to select a region of data. We're going to set something called flags to mark this as our important selection. We'll copy those data points, and we will continue on with our code. And you can see in just a few seconds, I now have an FFT that's scoped to just this segment of data. And so it's doing all the same operations that I showed you by hand, but we've used Python to fully automate this process. So you can really accelerate this workflow and do it at scale. Finally, I would like to highlight our integration with a product that we have called SystemLink. SystemLink is a web-based tool for systems management so that you can see the system health of a variety of distributed systems all in one convenient portal. It handles test asset management as well as test monitoring and distributed result collection. So you can see the status of any tests running on your testers, as well as have a single web-based location that you can upload all of your data results. And SystemLink also has an entire feature set that allows you to accelerate the analysis on that large volume of data, featuring tools to search and locate that data, schedule data processing, as well as data reporting. Now, SystemLink being a web-based technology, we have a really open web API that you can use to control SystemLink from a variety of environments, including Python. But there's one integration with Python in particular that I'd like to highlight with SystemLink. So there is a tool that you may or may not be familiar with called Jupyter Notebooks. It is a popular web-based tool for developing and executing Python scripts with inline visualization. And so we have integrated Jupyter Notebook into SystemLink so that you can use custom Python APIs that allow you to pull in data from SystemLink's data shares and do analysis with whatever Python libraries you want to use, as well as finally get your final test report out. And so having this integrated environment allows you to develop, debug, execute, and finally run your Python script, all without actually having to leave the web browser or the SystemLink environment. So this is a really neat integration, and you can see more online about how you can get started with Jupyter Notebooks in SystemLink. So in summary, today I've had an opportunity to show you a number of ways that you can use Python with the NI platform. You saw how to use the Python drivers to control our hardware. You've seen examples of how to invoke Python from NI software, like in the cases of LabVIEW and TestStand and SystemLink, as well as a couple of ways that you can use Python to automate our software, like we saw with LabVIEW and SystemLink as well. But everything that I've talked about today and more is available at ni.com/Python. So I encourage you to look that out if any of this interests you. So now we'll go ahead and open up the floor to questions, and thanks for coming out.
Okay, we're now going to open up the floor for any questions. So please just go ahead and any questions you have, type them into the Q&A box. But I'd just like to quickly mention that today's session is going to be recorded, and everybody will receive the recording afterwards. So I know for some of you, you were having a little bit of a hard time seeing some of the demos. Some of the video was coming through a little blurry. So the recording, you'll be able to see all of that a little bit better, and you can pause and zoom in. And before we take our first question, I just wanted to quickly introduce everyone who we have on our call this afternoon. So from NI, we have Austin Stanton. And we have a whole team from Computer Solutions. We have Steve, Andrew, and Jim. And if you don't know Computer Solutions, they're a partner of ours and NI. They're a strong team of engineers and scientists that are passionate about improving the quality, reliability, and safety of products through LabVIEW based systems for automated test, measurement, and control. They're dedicated to thinking outside the box to find the right solution for each application and each unique client. And then from our Testforce team, we have Ty and Ryan. So we're going to go ahead and start with the first question. And Steve, if you want to answer this one, what NI hardware can be used with Python?
Sorry about that. Okay. What I was saying is that, as mentioned in the presentation, DACMX is really the key. NI has put more engineering hours into developing DACMX even than LabVIEW. And it's an incredibly good hardware abstraction layer that lets basically essentially any language talk to any NI hardware with that's only a minor exaggeration. And so you can call from Python the start task and the task setup and end task and so forth, the same fundamental functions that you call from LabVIEW or anything to talk to any piece of NI hardware. And that's very, very powerful. It makes it very fast to set up communication with their hardware platforms. As far as I know, all the platforms are supported by Python through, again, the power of DACMX.
Great, thanks, Steve. So our next question, Andrew, if you want to take this one, what are the most common use cases for using Python with NI software?
Sure. So the idea of integrating Python with NI is to reuse and leverage the existing code that Python provides. And the example of the presentation was, for like analysis of various like Fourier transform or, having, often when people start design, they kind of code problem on the high level, on the system level using programming languages and then start implementing it in hardware and software. And that's where you can leverage that code that exists already in Python and bring it into the prototyping world. And that's very powerful. The word of caution I have is they call it bitness. You need to match up the version of your LabVIEW. For example, I'm using 32-bit LabVIEW, and then I try to use 64-bit Python software, and it don't go very well, so they have to be the same. So when I switched over to 32-bit Python, everything works really well. And there's this learning curve obviously with using this integration, and there's very good support via knowledge base from NI, and there's active community as we were told, and it really works very well. I mean, all my problems that I had with integration were solved rather quickly through someone, basically they existed references to type of errors. So thank you.
Thank you, Andrew. So we have another one here. This one came through just the chat. Which versions of LabVIEW are the Python function cells available in? Austin, would you be able to answer that one?
What versions of LabVIEW are the so the first version of LabVIEW that had the Python node was LabVIEW 2018, I believe. I can look that up, but see.
That's correct, Austin.
Yes, yep. So we introduced the Python node in LabVIEW 2018.
Awesome, thank you, Austin. Moving on to the next one. This kind of relates to it. Which versions of Python are currently supported?
Yeah, and I can answer that one too. So with the latest release of LabVIEW 2021, we currently support up to Python 3.9. I know there's 3.10 now, and generally newer versions are going to work, but it takes some time for us to test and validate the latest versions. While it would likely work with the newest version, we'll just take some time to test and validate that. But right now we have tested and supported all the way up to Python 3.9.
Okay, great. Thank you, Austin. And there's another one here that came through the chat. What kind of debug functionality is available in Python that can be similar to the LabVIEW debug function? Can you step through the line of codes? Austin, would you be able to answer this one, or is this one maybe we want to take offline?
Let's come back to this one after I have a second to think about the best way to answer it.
Okay, yeah, that's okay. We'll move on to the next question then. So we did have a question, where can I find more information for Python with NI hardware and software, and where can I see examples? I think Ty put the link in the Q&A box if everybody is able to see that. But if you go to ni.com/Python, you can find more information there, and we'll include that link when we send the recording out to everybody. And then our next question here is, can you explain the benefit of the Python node versus the system exec? Ryan, did you want to take this question?
Sure. The Python node allows you, it opens its own version of the Python interpreter, which allows inline I/O, so you can you can directly translate data and call LabVIEW data types into Python, whereas with the system exec, you would have to serialize that data and turn it into a string, which just requires more work.
Okay, yeah, thank you, Ryan. So another question here, I don't know if this one is maybe one we want to take offline. It's a little bit specific. Somebody is saying they have issues implementing tasks in Python that they know how to do in LabVIEW. Is there a place where they can get assistance implementing specific functionalities or support with syntax issues between the different languages?
I would just say for that one, on our GitHub, we do have examples that kind of walk you through and do a good job comparing a basic, the way you set something up, basically, if you're using LabVIEW and DIAdem to how you would set it up in Python. So you can kind of get a one-to-one situation for that as far as like using the API calls. If it's more Python specific coding, you need to know how you actually do particular things that are outside of what you would do in LabVIEW. I would recommend just reaching out to the Python community. That's one of the great things about the Python communities. There's lots of forums, lots of places where you can ask questions and get help there. And the more specific it gets to LabVIEW stuff, I'd say we on our NI forum have Python specific areas that you can go to ask those questions, and people have likely tried to do the same thing you're doing. So I wouldn't hesitate to just post on there and see if somebody can help you out.
Moving on to the next question. Does LabVIEW support Python virtual environments?
Yeah, let me really quickly circle back to the other one though, with the debugging Python code running inside LabVIEW or TestStand. So yes, both LabVIEW and TestStand have the ability to launch external processes. That's called ni python host.exe, and that'll be to manage and run the Python interpreter. So you can attach the Python debugger of your choice to this process to then debug Python scripts actually being executed in LabVIEW or TestStand. But note that if you're running multiple Python scripts in parallel, multiple instances of this process will run. So you'll have to have one instance for every Python script that is being executed. And then could you repeat the last question as well?
Yes, of course. So does LabVIEW support Python virtual environments? Was the question.
Gotcha. So Python does not directly So the Python node does not directly support specifying a virtual environment, but there is a workaround. So what you can do is you can activate a virtual environment using a shell script that is generated when you create a virtual environment. So then making a virtual environment active will add that virtual environment to the Python path variable so that any program using Python, including LabVIEW, will use that virtual environment. And there's actually a link that kind of goes through this that I will put in the chat right now. Let me just send this to the chat. So that is some Python documentation walking through virtual environments and packages. So that'll kind of help you get started with that.
Awesome. Thank you for sharing that, Austin. We'll move on to the next question. Can we write Python code in the formula node? Ryan, did you want to take this one? This kind of relates to the last question that you answered.
Yeah. Short answer is no, you can't. You need to use the Python node to be able to call Python files the .py.
Okay, easy answer. So the next one is about TestStand. So I don't know, maybe Austin or Ty, if you want to take this one. But the person is asking, what's the advantage of using a Python driver versus a LabVIEW driver to control instruments if the instrument driver is available on both Python and LabVIEW? And if this is a tricky one, we can always take this one offline.
I think, I mean, I can address it at least partly. So I would look at the quality of each driver and use the one that seems the most robust and most documented and so forth. And the other thing is, it depends on the rest of your environment, right? So if you're writing most of your application in LabVIEW, you might as well use the LabVIEW driver for consistency. And then if someone ends up supporting your code someday, they only have to know LabVIEW. And similarly, if your application's all in Python, you might as well use the Python driver so someone only has to know Python. That's at least part of the answer.
Yeah. We'll move on to the next one then. Can I send complex data types, including arrays, clusters, or images, to the Python node? Andrew, did you want to take that question?
Sure. So the answer is yes, we can send complex data types. And for example, if you use a video, sometimes you need to, for more complex data structures, you may need to resort to flatten that data using JSON objects. And that would be kind of, taken to the extremes. But for easy data structure, this just directly flow through this integration of Python and LabVIEW.
Okay, thank you. So our next question is a little bit specific, so I'm not sure if we'll want to answer this one after today's session. But this person is asking, how does the performance of multiple Python scripts execute through LabVIEW compared to the exploitation of Python libraries like multiprocessing? Is this kind of programming technique suitable for high-speed measurements?
So I can just jump in. I think getting more information for this one offline would be a good idea, reaching out, but there are going to be issues when it comes to synchronization and running multiple. When you're pulling these Python scripts into LabVIEW and you're running it in such a fashion, you're going to lose some amount of determinism, and you're not going to have as high of a level of control over everything. So, while I can't get too deep into exactly the technical details there, I can say that there will be some sacrifices being made on the control side.
Okay, thank you, Austin. I think that question was from Nicola, so we'll follow up with you after today's presentation, and we can get you some more information. So moving on to the next question, can I configure LabVIEW to work with Python from Anaconda?
Yep, I can take that one. So we don't have direct integration with Anaconda, but you can configure the path to point the Python command to Anaconda. And then we actually have a knowledge base article on this. Let me grab that and I can just put this into the chat. And this will give you more information about how you can configure TestStand to work with Python and Anaconda specifically, and then you can kind of just learn from there. So I've just sent that link, that knowledge base article link to the chat.
Great, thank you, Austin. Is it possible to use Python and with DIAdem, and how does that work?
So you can use Python with DIAdem in the scripting module within DIAdem, and that's going to allow you to automate certain processes. You can import data, visualizations, do some complex analysis and reporting. So basically just enhancing the features of DIAdem using Python. So
Great, thank you, Austin. So we'll take a few more questions. We're kind of coming to the end of our time, and we don't want to run over. So any last questions, just type them in the Q&A box. And if you have a more in-depth question, you can always reply to my email directly, or if the team wants to put their contact information below so they can be reached directly. If not, you can email myself and I'll connect you with the right person to be able to answer whatever your question is. So we'll take one last question. Will VBScript be replaced by Python for DIAdem? Austin, are you able to answer that one?
Yep, so no, scripting via VBScript is a long-time feature with DIAdem. It's not going to go away. We just want to offer flexibility, so we were adding Python as an additional ability to use Python instead, rather than replacing VBScript. So you'll still have all the benefits of being able to use VBScript, but then you can also use Python if that's kind of more in your wheelhouse.
Okay, great. Actually, we just had one more, and I think it's a quick one. So maybe we can answer this one as well too. Is there a way to put a breakpoint inside Python script? Austin, are you familiar with that?
So I believe there is a way to set up this functionality. I would want to follow up on with that to get you more information, just because off the top of my head, I don't have the best answer for you there. But I do believe that there is some functionality or at least a workaround for being able to do that. But
Okay.
yeah,
if
go
I
ahead and
can
follow
add
up
to
with more
it,
information.
yeah, it depends what platform you use to develop your Python code, and they all pretty much have those capabilities. So it's dependent on the environment in which you debug your Python code.
Awesome.
Okay, yeah. Thank you, Andrew and Austin. So maybe we can follow up with that question afterwards so we can get them the right information that's specific to what they're looking to do. But we'll wrap up the questions for this afternoon. I just want to say thank you to everybody for signing on with us. And thank you to Austin and the Computer Solutions team. If you think of any other questions after today's session, please feel free to reach out and we can connect you with the right person. You can reply to my email or you can email marketing@testforce.com. And if you're looking for more great technical resources like other on-demand webinars, white papers, app notes, you can visit our website, testforce.com/academy. And you'll be receiving the recording of today's presentation in a few days. So thank you to everyone, and I hope you all have a great day.
Thank you.
Thank you, everybody. Have a great day. Take care.
Thanks, everybody.